let's do a quick refresher from what we did yesterday. We talked just about the basics of exponents, and we hit some common mistakes, which I will go a little further into the fixing of the common mistakes today. But exponents, things like a to the power of b. A, again, is called the base, and b is the exponent or power. You'll hear it referred to as both. You'll hear it referred to as exponents or to the second power, let's say. So if you said you had a here, this would be a to the second power. Okay? Or it could be a squared. These are two ways of saying the same thing. Let's say you had a to the third power. That's what this is, to the third power. Or it can be called a cubed. After you pass the third power, then from the fourth power on up is just a to the fourth power. There is no word for the fourth power like you have cubed for the third power. There's no word for the fourth power. It's just a to the fourth power, and so on and so forth. It continues to go up from there to whatever power you want to take it up to, right? So today we're discussing the product rule. The word product means to multiply. Product rule is to multiply. Okay, so it's when we multiply two exponents or two bases or two exponents with the same base. Say it so many different ways, but you're multiplying two products that have the same base. Product rule. It says when you multiply let's say products. When you multiply products with the same base, you add the exponents. That's what the rule says. That's what the rule says. When you multiply products with the same base, you add the exponents. So an example of this would be like the one I showed on the front of my graphic. X to the m times x to the n is x to the m plus n. You add those exponents. Notice that you had to have the same x here as the base. This does not work if you have, for example, y to the m times x to the n. You cannot do, y, x, m, n, or however you want to do it. No, you can't do that. That's not how that works. Okay, you must have the same base. The base here is the x. Then you have the exponents. You add the exponents. That is what the product rule is called. Let's use some examples. Let's do some examples. So let's say we have, let's start with x's again. X to the third, and we're multiplying that times x to the fourth, let's say. This gives us, we keep our same base. We add the exponents together, x to the 3 plus 4, which is x to the 7th power. When you multiply exponents or products with the same base, you add the exponents. Okay? Let's see if we have some letters here. Let's say we've got x squared y cubed, and we're multiplying that times, let's say x to the 5th and y to the 7th. You can only put the bases together that are the same. You just don't make this x, y, and then add up all the numbers. Not the way that goes. Okay, so let's put the x's together and the y's together. Let's put x squared and x to the 5th. Let's put those together. And let's put the y's together. Y cubed and y to the 7th. Putting these together so that way we can see the same base here. These both have the same base of x. These both have the same base of y. Now we can apply our rule. This is going to be x to the 2 plus 5 times y to the 3 plus 7. Our answer is x to the 7th, y to the 10th. And you do not try to put that together and do xy to the 17. No, that's against all the rules, or at least against the product rule. You cannot do that. You can combine the bases that are the same, add the exponents, but x's and y's are like apples and oranges. We do not put them together and then add the exponents. Against the rules. Against the rules. Okay, let's see if we had some numbers. Say we were doing 2 to the 3rd power, and you were multiplying this times 2 squared, let's say. Well, these bases are the same. The base is 2. So we can put those together. We keep the 2 to the 3 plus 2. Notice I did not multiply 2 times 2 and then say this is 4. That's a common mistake that's made. Don't do that. Even though we're talking about numbers, like over here, we couldn't really put the x's together too much because we don't know what x represents. And in this case, you have a 2, but the 2 is the base. It remains the same. Just like over here, the x remained the same, and then you added the exponents. The same thing happens with the number. The base remains the same, and you add the exponents. It's not a mistake we want to make. So we have 2 to the 5th power. Well, 2 to the 5th power is the same as 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 more is 8, times 2 is 16, times 2 more is 32. Okay, this is how we do with numbers. Let's think about combining something together here. Let's say we've got 2x squared y times 3x cubed y squared. Let's go with that. Another example. Well, in this case, the 2 and the 3 are not operating like exponents. They're operating like coefficients. Coefficients are the numbers in front of the letters. So we put our 2 and our 3 together. We're doing products here. So 2 times 3. Let's put our x's together, x squared and x cubed. Let's put our y's together, y and y squared. Question, does anybody here know what is the exponent of this y? If you don't see an exponent, then what is that exponent? Anybody out there have a clue? Any guesses? Well, I'll tell you. Anytime you don't see an exponent, then there's an invisible 1. It's called the power of 1. If you don't see an exponent, then 1 is the exponent. It's not written. Just like when you see the number y, you don't see it written as 1y. You just see the number y, the letter y. Sorry, not the number y. You just see the variable y. You know, nobody really writes 1y. It's understood that there is a 1 here, even though you don't see it. Same thing happens with this y variable here. The exponent is a 1, even if you don't see it. Okay? So now let's go back to our problem. We've got 2 times 3. 2 times 2. Oh, good job, Boris. I see you. I see you. Yay. So 2 times 3 is 6. X squared times x cubed. And then we have y to the 1 plus the 2 here. So our answer then is 6. X to the 5th. Y to the 3rd power. Anytime you see a whole bunch of pieces and parts, sometimes people get confused thinking there's just too many things in one place. But if you just break them out into parts, so you take the coefficients together, You take the x's together, you take the y's together, and then you work on them all individually. And before you know it, you will have it marked down, or you will have it simplified to the point where you have an answer. So let's see, do we want to try another one together? Let's see if we can try one together. Okay, so let's pull in some letters. So I try to keep our numbers simple on these videos so we don't get ourselves too involved. 3 squared, let's say m cubed n to the 4th, and let's get involved. Let's see if we learned anything here. Times 3 m n squared p to the 6. Okay, I'm going to give y'all a few seconds to think about what would happen with our problem. Okay. First, again, like I told you, let's put our coefficients together and then put the same variables together so it'll be easier for us to simplify things. So we'll put our 3 squared together with our 3. Those go together. Then let's put our m's together, m cubed and just m here. Then we've got n to the 4th times n squared, and p to the 5th, p to the 6th. Put all of our separate variables together so that way it's easier to see how do we simplify them. Many times we try to do too many things in our head and then we get ourselves confused. If we just write 1 or 2 more steps, we'll get it. Okay, so 3 squared, there's an invisible 1 up here. So these are the same base, so this is going to be 3 to the 3rd power. M cubed times m, again, another invisible 1 up here. This is going to be m to the 4th power. N to the 4 times n squared is n to the 6th power. P to the 5 times p to the 6 is p to the 11. So we're not quite done yet. We have to do one more step where we go ahead and multiply out our numbers. 3 cubed is 3 times 3 times 3, which is 27. 27, m to the 4th, n to the 6th, p to the 11th. That is our answer. I hope that's what y'all got. Did y'all get that same answer? Were y'all doing it so that way you could work along with me? Okay, so now we've looked at the product rule, which is the rule for multiplying exponents or products with the same base. Anytime you're multiplying products with the same base, you add the exponents. We did several examples to show us how we add the exponents and we put things together. Okay, so we've done some practices. I did some simple ones. Let me pull it back down. We've done some simple ones. We got a little more involved as we went. And then we got all the way down to the bottom where we had several variables. Now, these are the kinds of things, again, that I go over, that I will go over for sure, much more in depth in my course. But I always want to hit a little bit of basic knowledge so we can have something to work with. Do we have any questions that we want to? Anything we need to clarify? Anything that we'd like to know out there in Facebook Live land? Anybody want to know anything? If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemaths.com where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathshelp.com. We look forward to seeing you there.